we are going to learn how to perform arithmetic operations on numbers and present the final answer to the right number of significant figures. So you must have encountered some questions or problems that asks you, present your answer to the right number of significant figures. So we're going to learn how to do that. There are a few rules here. One rule is related to how to perform multiplication, division, and taking roots. One other rule is related how to perform addition and subtraction. And then there is one exception that relates to all of these rules. And lastly, we're going to mention just one caveat, one caution to remember while doing these operations and showing your final answer to the right number of significant figures. Let's talk about the first rule. So your final answer when you're multiplying several numbers or dividing or taking roots, the significant figures in your final answer should match the number of significant figures in the least precisely known number used in the calculations. That means the least precisely known number means the number with the fewest number of significant figures. Let's see an example. So when you're multiplying, let's say 3.5 by 1.51, what do you have to do? So first you perform the operation as per usual, either manually or with a calculator. So I have a calculator here, 3.5 multiplied by 1.51. What do I get? So the calculator is giving me 5.285. Now, the question is, what is the right number of significant figures in my answer, in my final answer? And according to this rule, since we're doing a multiplication, so the first rule is applicable, what is the least precisely known number here? So 3.5 has how many sig figs? It has 2. 1.51 has 3. So the least precisely known number is 3.5 because it has the fewest number of significant figures. So what I do, I keep only 2 significant figures in the final answer. That means only these 2. From left to right, 1 and then 2. That's it. The rest will be discarded. But the immediate next number that we're discarding is 8. And since 8 is greater than or equal to 5, we have to round this to up. We have to round it to 3. So the final answer will be 5.3. That's it. So this is how now our final answer is presented to the right number of significant figures. Only 2 significant figures, and the 2 has been rounded up to 3 because the next digit, the immediate next digit to 2 is 8, and 8 is greater than or equal to 5, so we round it up. Let's see another example. Imagine these 2 numbers now, they were divided by each other. Same thing. First we perform it usually. So again, I put it in calculator, 3.5 divided by 1.51 equals. So the calculator is giving me a very long number. 2.317 and then 8 and then blah 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 blah, like continues. But I don't even gonna write those because we know we're gonna keep the final answer to the same number of significant figures as the least precisely known number. The same scenario, 3.5 has 2 sig figs, 1.51 has 3, so 3.5 is the least precisely known number, and again I keep only 2 sig figs in the final answer. The next digit that I'm discarding is 1, and 1 is less than or equal to 5, so there's no need to round up. It stays as 2.3. Let's see another example. Let's say we are taking the roots from something like 3.61. We're taking the second root from this number. First, we perform that normally, and here I get 1.9 in the calculator. What was the least precisely known number that we had? It was 3.61, and it has 3 sig figs, right? The final answer here has just 2 significant figures. So the right representation of this number to the right sig figs is 1.9, and also we add 0 here, so that we have in total 3 significant figures, just like the answer. So we are reminded of the precision of those numbers that we crunched, that we performed these calculations on. Let's now go to the rule that is related to addition and subtraction.
Let's go.
So in here, we consider the number of decimal places in the final answer. Now, we're not talking about the total number of significant figures in the final answer. We're just talking about the number of decimal places in the final answer. And the number of decimal places in the final answer should match the smallest number of decimal places of any number used in the calculations. So the number of decimal places in the final answer should match the smallest number of decimal places of any of the numbers used in the calculations. Let's see an example. So let's say 7.21 minus 3.3715. Let's say you have gotten these two numbers from 2 different measurements, and those measurements tools were different, so one of them was more precise, one of them was less precise. In here, because we're dealing with subtraction, so it's related to the second category. Now we care about only the number of decimal places. So here we have 2 decimal places. Here we have 4 decimal places. So our final answer, we know already, should match the smallest number of decimal places. Our final answer should have just 2 decimal places. So now I go ahead, I perform this operation as per usual. I put it in the calculator. So the answer that I got is 3.8385. In our final answer, we're looking for only 2 decimal places. So equals 3.80. Now, immediately the next number that I'm deleting, that I'm omitting, is 8. And 8 again is greater than or equal to 5. So I have to round the next digit here. So 84, 3.84. Let's see an example with addition. Let's say 2.356 plus 5.21. What about this?
What about it?
So we're performing addition, the second category. This first number has 3 decimal places. The second number has 2 decimal places. The smallest number of decimal places is 2. So our final answer should have 2 as well. 2 decimal places. So I performed this addition. Here's what I got from the calculator, 7.566. Now, since we're keeping only 2 decimal places, I'm looking at immediately the next digit is 6. 6 is greater than or equal to 5, so I have to round this up. The digit that I'm keeping before that has to be rounded up. So 7.57. That's the final answer presented to the right number of significant figures. There is one exception to all these rules, and that is regarding the exact numbers. What do I mean by exact numbers? So you remember, these significant figures, they become very important when we are doing some measurements, reading numbers off of a measurement tool. But what if we're doing like plugging these numbers that were measured into a certain formula? And that formula, for example, let's say you measured the radius of a circle, and now you want to measure the diameter. Diameter equals 2 times the radius. Now, this 2 here, it has one significant figures, but we don't really care about this 2, and we don't get it involved in these rules. We don't consider it with these rules because it's an exact number. So, exact numbers, we disregard them from these rules. Now, one caution to always be aware of, and that is when you're doing some long number crunching and you have multiple intermediate steps, let's say you're solving a physics or chemistry problem and you're dealing with rounded up, then you're gonna have a lot of error at the end. So it is recommended in your intermediate steps, so in your intermediate operations, keep 1 or 2 extra sig figs. Meaning when you're reading off of your calculator, always if it's an intermediate step and you're still far from your final answer, keep extra significant figures. Even you can just keep the original number that you read from your calculator. Keep it original, the entire number, and then your final number, your final answer, present that to the, according to these rules. Present that to the right number of significant figures. Let's see another example.
Let's see.
Suppose you want to measure the area of your room, and you have a rectangular room, and you start measuring with a tape that you have, and is precise to 0.001 meter, that tape, and you start to measure this length, this short length of your room, and you record that short length is 3.547 meters. You start to measure the longer length of the room, and you realize your tape is too short, so you borrow another tape that is 0.01 meter. It's only precise to 0.01 meter. And you record the other length as 4.79 meters. So the area of the room, you know, it's made up of multiplying the one length by the other because your room is rectangular, so it's 3.547 multiplied by 4.79. Now, you're dealing with multiplication, so what is the least precisely known number? This guy has 3 significant figures. This guy has 4 significant figures. 4.79 is the least precisely known number. Now you go ahead and perform the calculation as per usual, and I got from the calculator 16.99013. So the final answer should have 3 sig figs, and that's 3 sig figs. But the immediate next digit is 9, and 9 is greater than or equal to 5, so I have to round this up. So that's 9 rounded up becomes 10. So 0 is kept on this position, and the 1 is given to the 6 here. So 6 becomes 7. So 17.0 is the final answer, presented to the right number of significant figures. But let's say if you wanted to calculate how much you have to pay to carpet your room, the entire area of your room. And the price of carpet was something like $8.99 per meter square. How much do you have to pay for carpeting your entire area of your room? So you know the area of your room, you have calculated it. So total price, we have to multiply the 8.99 by, so what number should I use to multiply 8.99? 17.0 or the original number that I got from the calculator? So this is the caution that I told you about comes into the picture. If you use 17, your answer wouldn't be as accurate because we have already rounded that number up. So it's better. Now the calculation of the area is considered an intermediate step. So it's better you use a few more digits here. So you better to include 16.99 and then include a couple more digits, 0, 1. Even you could include the entire number, no problem. And then calculate the answer. In that way, you will get a more accurate answer. So I perform this with a calculator again as per usual. So this is the answer that I got. 152.7412,687. Now the question is, how many significant figures should we keep? And the answer is, it should match the number of sig figs of the least precisely known number. What is the least precisely known number? Now you have to scan all of your calculations. So this guy had 3.547, the short length of your room. The long length of your room had 3 significant figures, 4.79. Do we have to at all consider the price? 8.99. Does it have 3 sig figs? Do we have to consider it? Or is it an exact number? Exactly. This is an exact number coming from the measurement. You went to the market, you know now if that carpet that you want to buy is $8.99. That's it. You didn't use any measurement tool to measure that number. So this is now considered an exact number. And you don't consider it. So still the least precisely known here is 3 significant figures. So you keep 3 significant figures here as well. And that's it. So the right presentation of number, and the next digit that is getting eliminated is 7. 7 is greater than or equal to 5. So this has to round up, and it will round up as $153. That's how you do it. Now, suppose you wanted to measure the perimeter of your room. And we know the formula for perimeter is 2 times one length plus 2 times the other length, right? So it has to be 2 times 3.547 plus 2 times 4.79 equals. Now, in these multiplications, again, this 2 is an exact number because it's part of the formula. The 2 is not coming from a measurement tool. This is just part of the actual formula to measure the perimeter. So since 2 is an exact number, we just perform that operation as usual with no change in significant figures. So 2 times 3.547. The answer to that is 7.094 plus the other one, 2 times 4.79 equals 9.58. Now we're dealing with a addition. So which one has the smallest number of decimal places? This one has 3 and this one has 2 decimal places. So again, we perform the actual addition as per usual, and then we get 16.674. Now the smallest number of decimal places are 2, and the next digit is 4, 4 is less than or equal to 5, so I don't need to do any round up here. I just keep the answer is 16.67 meters. That's the perimeter of this room. So overall, that's how we perform operations on numbers, measured numbers, and keep the right number of significant figures in the answers. Hope you guys enjoyed it. Let me know if you have any comments, questions, and please subscribe to support the channel.